All right, guys, here we go. Here we go. Notes 5, Intermediate Value Theorem. Sometimes you'll see the abbreviation IVT. Try not to say the acronym. Try to just say Intermediate Value Theorem and more on continuity. We're going to start with the continuity. So here we go. Look at this example. So this is a piecewise function. It behaves like kx squared plus m for x less than negative 2. It behaves like 4x plus 1 between negative 2 and 3. And it behaves like kx minus m for x greater than 3. It says, what two limits must be equal for g of x to be continuous at x equals negative 2? Well, the two limits that must be equal from the left-hand side, so I'm going to write limit as x approaches negative 2 from the left of this function, kx squared plus m, that's the one from the left. It better be equal to limit as x approaches negative 2 from the right of 4x plus 1. And of course, for it to be continuous, that also has to equal g of negative 2. That's the definition of continuity. Limit from the left has to equal limit from the right, which equals the function evaluated at that value. Does that make sense? I guess technically they asked for the what two limits, so I guess technically the answer is these two limits, but I wanted to put that g of negative 2 in there to enforce the rule for continuity. Because in delta math, when you do it, it's going to say, remember how we did it last time? Yeah, I put the same one again. Limit from the left, limit from the right equals whatever. What's up?
You know how like when limits we don't care whether it's an open circle or closed?
Well, yeah, but now we're talking about continuous. So it needs to, from the left and the right, and that hole needs to be plugged in. So that's why I wrote g of negative 2. So not only does the limit have to exist, but it better equal g of negative 2. So now I don't want that open circle.
So if the limit doesn't exist, it doesn't.
No,
Can't be continuous.
you're right. If the limit doesn't exist, you can't be continuous. All right. What two limits must be equal for g of x to be continuous at x equals 3? Well, limit as x approaches 3 from the left. Let's see, what function is that? That's a 4x plus 1. That better equal the limit as x approaches 3 from the right, which is the kx minus m, and all that better equal g of 3. And I just put this in here for continuity, because that's the definition of continuity. Continuity. Yeah, I can't spell today. Are we still okay, guys? All right, determine the values of m and k so that the function is continuous everywhere. Okay, no big deal. This is the one that we're going to use. See how right there, this helps me figure out what that output is? Let me. So we're in 9th grade. So here we go. Limit as x approaches negative 2 from the right of 4x plus 1. I'll just write it as 4x plus 1. That better equal 4 times negative 2 plus 1. So negative 8 plus 1, negative 7. So I'm going to equal, so here's equation 1. I'm going to go negative 2 squared is 4, so 4k plus m. That's equation 1. And that output better equal negative 7. Is everyone okay with what I just did there? Yes. Yes. I don't know what this value on the left equals, but I do know what this value on the right equals because I only have one variable. So I just did 4 times negative 2, that's negative 8, plus 1 is negative 7. So in order for this one and this one to be continuous, I need to make sure that the y values are approaching the same value. So that's the only way that they're going to be touching. Does that make sense? I need the left-hand side and the right-hand side to both equal that same y value. If they don't, then forget about trying to be continuous. Does that make sense, guys? Well, I'm about to use 3. I just did letter A first, and now I'm about to do letter B. All right, so here we go. Limit. Four times 3 is 12, plus 1 is 13. So that means this guy right here better be approaching what value? 13. So I'm going to plug in a 3 for x. 3k minus m equals 13. And this is why algebra was so important. And I'll slow down. Now you're just doing algebra. You're done with calculus. You're just doing algebra. I have these two equations. It looks like, from looking at it, it looks like I can just add both of these and the m's will cancel out. Do you guys see that? So 4, 5, 6, 7. So I have 7k, and then these m's cancel out equals, and then the difference between 7 and 13, what's that? 7, 8, 9, 10, 11, 12, 13, 6. So k equals 6 sevenths. I got my, oh, OMG. Yeah, I walked into that one. 6 over 7. All right, ready? Now that I got the k, can I get the m? It does not matter which one you use. I guess we'll use this one because the m is positive on this one. So here we go. 4 times 6 over 7 plus m equals negative 7. Let's see. 4 times 6. 6, 12, 24. 24 over 7. Focus, guys. Focus. Plus m equals negative 7. And from... I just took it from the equation. I already know what k is, so I can grab whichever one. Yes. Yeah. I'm just doing algebra, miss. M equals negative 7 minus 24 over 7. Relax. I'm going to turn that negative 7 here into a common denominator. Negative 49 over 7. That's still 7. Minus 24 over 7. Everything okay, guys? Let's see. 49, 59, 69, 73. 73 over 7, no? Yeah. It should be the same m if I were to use equation 2. Should we just try it just for kicks? Okay, let's just try it. Oh, well then that means this is all wrong. Because I need to find, their k and your m have to be the same. All right, let's see. 3k, which we already know what the k was. K was 6 over 7. Minus m equals 13. I'm just going to move these two like that. So I'm going to say, let's see, 3 times 6, 6, 12, 18. 18 over 7 minus 13 equals m. Let's see, what's 13 times 7? 81? I'm just going to... I'm sure you're right. 13, 13, 13. Yeah, I think you were right. 13 times 7. 91. Yeah, you were right, miss. Okay, so minus 91 over 7 equals m. Is that the same thing as 73 over 7? Negative? 18 minus 91? 18 minus 91. Yep, there you go. What? I did it right. We got negative. Which is what we had here. 18 minus 91, or I guess 91 minus 18, but change the sign to a negative because 91 is bigger. So even if you would have done equation 2, you would have gotten the same thing. I just think equation 2 would have been a little tougher. Does everyone know what we're doing, guys? Okay, so what do? Limit from the left has to equal the limit from the right, which has to equal that function at that x value in order for it to be continuous. Cool? Okay, let's go to the next one. This is coming from UH. Yeah, I already put, I think, I don't remember who it was. If you want to say your name, that's fine. If you don't, that's fine. One of you wanted the UH quizzes on the calendar on Canvas. So whoever it was that told me about that, I just went ahead and started putting the UH quizzes on Canvas. Do you guys like that, to have the UH quizzes on Canvas? Okay. So there it is. I already uploaded yesterday. As soon when I got that email, I was like, okay, I'll put them up in there. So I put all the UH quizzes on Canvas now, so they're all there for you to have a reminder of when they're due. So continuity quizzes are now ready to go. This one is coming from UH. This is one of the questions. So here we go. Next week, yeah. Given that I have this function, define the function f of x at 5 so that it becomes continuous at 5. Well, remember what the rule is. Limit as x approaches 5 of f of x better equal f of 5. And I know I didn't say from the left, from the right. Look, there's no plus or minus. So when there's no plus or minus, that means I'm checking from the left and the right. Does that make sense? So first, I got to figure out what this limit is. If it has a limit, if it does not have a limit, there's nothing you can do to make it continuous. So don't write this down, just listen. So if I were to tell you, here's this function. So if I have a function like 1 over x minus 5, I would hope that you know that at x equals 5 is a vertical asymptote. So note, I'm just doing this on the hand side, on the right-hand side. Limit as x approaches 5 of 1 over x minus 5. Oh, look, does not exist. This function here, no matter what you do, you can never make it continuous. You can never make it continuous. Does that make sense? Okay, it's not this function, so now let's go ahead and work with the red one. Does it have a limit? Well, let's find out. Limit as x approaches 5 of the square root of x plus 4 minus 3 over x minus 5. I cannot do direct substitution. What is making this function hard? The numerator or the denominator? The numerator. So I'm going to multiply this limit by the square root of x plus 4 plus 3 over the square root of x plus 4 plus 3. Chav, why'd you do that? Because when I do that, this kind of creates like the difference of squares in the numerator, and it makes life easier for me. So check it out. Square root of x plus 4 times square root of x plus 4, x plus 4. Negative 3 times positive 3, minus 9. Don't distribute the bottom, leave it like this. Bless you. Limit as x approaches 5. In the numerator, I have x minus 5. In the denominator, x minus 5, square root of x plus 4 plus 3. Hopefully, you're getting now enough experience that you can do these like that. What's going to cancel out, guys? The x minus 5. Bam, bam. Now can I do direct substitution? Yes. Limit as x approaches 5 of 1 over square root of x plus 4 plus 3. I guess you don't need those parentheses there. 5 plus 4 is 9. The square root of 9 is, and 3 plus 3. That is my limit. Chav, you haven't answered the question yet. Look, that's my limit. Don't worry, I'm going to answer the question right now. Look what it says right here. Define the function f of x at 5 so that it becomes continuous at 5. So here it is. I'm just going to do a piecewise from algebra. So I'm going to write f of x equals, and I'm going to go like this, put a little bracket, and I'm going to go, and I'm going to write square root of x plus 4 minus 3 over x minus 5 as long as x does not equal 5. So what this is telling me is as long as x is not equal 5, you do this. But when x equals 5, what do I want the output to be? And there it is. Now f of x is continuous for all real numbers. Yes.
Why did you do the blue?
It was just an example of how if the limit does not exist, then forget about it. You cannot do anything to make it continuous. Because I have an infinite discontinuity at x equals 5. I think UH has it written like this, guys. It says f of 5 equals 1, 6. That's the same thing. When x is 5, what's the output? 1, 6. Cool. Say it again.
Now do we use the piecewise function to do what we did in the last problem, or
No, you're done. You're done. How do we feel? Okay. IVT. Relax, guys. We're almost done. You want to read this and tell me if it makes sense to you? What do you think, Kyle? Did it make sense to you? Okay. Yeah, go ahead and read it. You want to read it out loud? Yeah, read it out loud.
The function y equals f of x that is continuous on a closed interval a and b takes on every value between f of a and f of b. In other words, if y0 is between f of a and f of b, then y0 is equal to f of c for some c in a.
Oh yeah, that makes sense. Okay. I think they think everyone's a math major. All right. These are x values. This is some x1, that's some x2. And then f of a is a y value, some y value. I'm just going to say some y. So this is another some y. And then it says y naught is between these y values. That's all. And when you say y of 0, this usually you say why not. Why not? Or y initial. In physics, they'll say that as initial. Hey, peace. We're good. All right, here we go. Here we go. Sorry, guys. In layman's terms, all that means is that your y value, if you're continuous, okay, let me, what's the simplest way? Okay, right here. Look, I have a point. I'm going to say that point is 2, negative 5. I have another point. I'm going to say that point is 4, comma 4. And I have a curve. The curve is continuous. That's what it's saying. That's what this is saying. It's continuous on a closed interval. So it's saying if I was at negative 5 right here, and then I was at 4 up here, did I cross the x-axis if I'm continuous? Yes. How many times did I cross it? Well, in this case, I crossed it once. But if we don't know how the curve looks, I could have crossed it many times. You don't know how many times you crossed it, but you know you definitely crossed it once at the very minimum. Does that make sense? Okay, that's all it's saying. That's all it's saying. So let's see what this scenario here says. You're driving to a calculus Saturday session for your first mock exam, which has to be your favorite class because you already know you're going to pass the AP exam. Yay, go Cardinals, math life. Yeah. I believe that statement, guys. You look down at your speedometer, it says 55 miles per hour. Did you, at any given moment before the instant you looked at your speedometer, travel exactly 52, 59 miles per hour? Okay, so let me tell you what the scenario is. You're driving, you look down, and it said 55. At any time before you saw that 55, were you traveling 52 miles per hour?
Yes.
You had to. The only way you can hit 55 is if you hit 52. Did you at any time go 59 miles per hour?
No.
Maybe, but is it guaranteed?
No.
That's what the Intermediate Value Theorem says. Maybe you hit it, I don't know, but you definitely hit every value between 0 and 55. That's all it says.
How do you know that?
Because the only way you can hit 55 miles per hour is if you pass 52 miles per hour.
No, but in math terms, in the intermediate value theorem.
By the Intermediate Value Theorem, my initial time was 0. And at that moment that I saw my speedometer was 55. So by the Intermediate Value Theorem, I have to have hit every value between 0 and 55.
Well, I was just asking how it looked like.
No, you literally just say my initial value, velocity initial is 0. Velocity at some moment in time, I don't know, you want to call it T1, is 55. So somewhere between 0 and T1, I had to have been going 52 miles an hour by Intermediate Value Theorem. That's it. Does that make sense, guys? All right. So let's see. Look, we're about to do one with math here. What's up? Oh, sorry. Can the IVT, and I'm doing such a bad job of, do not use the acronym, Intermediate Value Theorem. Don't use the acronym. Say the whole thing. Can the Intermediate Value Theorem be used to show that there is a solution for the equation? Look what they wanted. They wanted to equal 0. On the interval, these are x values. x1 is 1, x2 is 2. If f of x equals that, give an explanation why. Okay, here we go. F of x is continuous on this interval. So I'm going to state that f of x, it's just a polynomial. F of x is continuous on its domain. All real numbers. I guess I could have used a capital R. You guys ready? F of 0. Oh, f of 0. F of 1 equals 3 times 1 cubed minus 5 times 1 squared plus 1 minus 3. Let's see what that is. 3 minus 5, that's negative 2, plus 1, that's negative 1, minus 3, that's negative 4. So I think that's negative 4 if I counted correctly. 3 minus 5, negative 2, plus 1, negative 1, minus 3, negative 4. Okay. So f of 1 is negative 4. Okay, now I'm going to do f of 2. Yeah. Remember, guys, it's continuous. Chop, what are you doing? What is the plan? All I'm doing is I'm plugging in a 2, and if I get a positive number, I know for a fact that f of x had to equal 0 somewhere between 1 and 2 because it's continuous. Oh, we're just in sophomores. So here we go. 3 times 2 cubed minus 5 times 2 squared plus 2 minus 3. Let's see what this is. 8 times 3, 8, 16, 24. Minus 10, minus 20. Sorry, guys. So that's 4 plus 2, so that's 6 minus 3, so that's 3. So I'm going to say right here that f of 2 equals 3. All right, focus on these two numbers right here. Did I cross the x-axis? Yes. How many? I don't know, maybe more than once, maybe twice, maybe 3 times. But I at least crossed it once. So I'm going to say by intermediate value theorem, comma, since f of 1 equals negative 4 and f of 2 equals 3, comma, there must exist, let's see, usually they say the c value. There must exist a c value, and the c value is just an x between 1 and 2, where 1 less than c less than 2, such that f of c equals 0. Boom, full credit. I already stated that f of x is continuous up here. Let's see if this makes sense. I'm just saying that c is between 1 and 2 because that's the interval. So look what I said. By intermediate value theorem, since f of 1 equals negative 4 and f of 2 equals 3, there must exist a c value between 1 and 2 such that f of c equals 0. That makes perfect sense to me. Does it make perfect sense to you? Okay. What's up, Anderson? Hit me. Okay, yeah, tell me. That's why I caught you. Tell me. You don't have to say it this way. You could have also said, since f of x is continuous and f of 1 equals negative 4 and f of 2 equals 3, f of x must equal 0 somewhere in that interval. It doesn't have to look like this. I just wrote it like this because this is how it is, how you usually write it historically.
What's the C value?
C value is some x.
Basically saying that you passed the X.
That the x is somewhere between 1 and 2, that I hit 0. See?
Are we only concerned about x then?
You're only concerned about the interval 1 and 2. Because
Is what it gives us?
well, 1, they told us to only look at 1 and 2. And 2, we only use the intermediate value theorem between 1 and 2 to see that it does equal 0 somewhere. We don't know if it crosses 0 somewhere between 5 and 10. We didn't calculate that. We just calculated between 1 and 2.
So we just care about the x-axis and the y.
Well, that's the only time that the y value is 0.
Could you have also written like bracket 1, 2, bracket?
Yeah, it would have been fine. But I know that I don't hit it at 1. And I know that I don't hit it at 0. Hit what? I know that this function is not 0 at 1 and at 2, so that's why I didn't put equal signs. But you could have if you wanted to. You're not wrong. Hit me, guys. Hit me. We're good? Okay.
So basically, it's just like you're substituting. That's all you're doing. Whatever you're doing.
Yeah, I'm just plugging in my 1 and my 2 and just seeing what the values are, right? I don't have it. They don't have to equal 0. I mean, obviously, I crossed the x-axis. I could have equaled. Okay, tell me this. Does the intermediate value theorem tell me that between 1 and 2, f of x equals 1? Yes. What about f of x equals negative 1? Yes. What about f of x equals 2? Yes. What about f of x equals 5? No. Only the y values between negative 4 and 3. Maybe you hit 5, but we don't know that by this. Cool or not cool? Okay. How do we feel, guys? Ain't no yelling. That's a demerit. What, you didn't think I caught you? I caught you. Chavez 27, Esquivel 0. And it's on record now. It's being recorded, so that's it. That's it. I want. Not even. You know what? You're on my blacklist. I'm kidding, miss. I don't have a blacklist. Stop, you know. All right. Oh yeah, you guys know me. Attempt and due date.
But like I forgot.
Yeah, yeah. That's
I told you
That's why I put. That's why I started putting them on attempt and due dates. So guys, you guys know me. You guys had me last year.
Can you put the attempt dates in Canvas too?
Yeah, I did. It's in there. Attempt.
And the due dates?
Yeah. I put yeah. It was yesterday. All right. Here we go. There's a new law that goes into effect this August. I cannot pronounce this. How do you pronounce that? Atchafalaya Basin Bridge. True story. Go look it up. The bridge is 18 miles long and is part of I-10. So if you guys ever travel that way, the new law allows the use of cameras to support issuing a ticket based on how fast it takes a vehicle to get from one end of the bridge to the other. Drivers who cross the bridge in less than 18 minutes will receive a speeding ticket in the mail. Okay. How fast is this? What's the speed limit? The bridge is 18 miles long. Yeah. Speed limit is 60 miles per hour. If you travel 60 miles, you'll travel 18 minutes. You'll travel 18 miles in 18 minutes. Right? Yeah, relax. If you don't know that, relax. Look, you could have taken the miles and the minutes. You could have gone 18 miles and you travel 18 miles in 18 minutes. Don't worry. We're going to transfer this to miles per hour. And there's 60 minutes in 1 hour. So notice that the minutes cancel out and you get miles per hour. The 18 and over 18 is 1. See, that's just 1. And you just get 60. And then you get what? Miles per hour. So that's the speed limit. Cool or not cool? Yeah. All right, check it out. Use the Intermediate Value Theorem to explain, is this law fair and just to all drivers? Why? And then I put make a 1-minute speech, but you know what? We're taking pictures, so we're not going to do that. Because of the pictures is going to take away that time that we would have used for this. All right. Okay, do you guys know what's happening first and foremost? You're driving. As you enter the bridge, there's a camera. It takes a picture of your license plate. When you finish at the end of the bridge, there's another camera, and it sees how long you took. If you took 18 minutes or longer, it does not give you a speeding ticket. If you took less than 18 minutes, boop, speeding ticket. Why?
That's messed up. Because you're going 61 miles per hour.
Because how is just people acting like 60 on the road? Like if I'm driving 60, everyone's like zoom past me. That's scary.
Hey, I'm not making the rules. If you, and I guess there is such a thing as mean value theorem. We haven't talked about that yet, but if you pass this bridge in less than 18 minutes, your average speed is faster than 60 miles per hour. Yes? So by IVT, if your average speed was 67 miles an hour, well, then you had to have been going above 60 at some time because you went through it so fast. Does that make sense? This one's probably closer to MVT than IVT, but don't worry, we'll talk about those later. But do we see what's going on? By the way, guys, if there's a toll road that has cameras, just pull over and get some gas. And then your average speed will definitely be a lot lower than whatever the speed limit is. So, I mean, yeah, that's why I always, if it's a toll road, if I'm in Houston and it's a toll road with a lot of cameras, I will pull over to buy something every time. Yeah, I need gas, even though you have like almost a full tank. Just pull over somewhere. Yeah. Because you probably have a car that you can't tell the speed. Like you can't tell that you're going fast. What type of car is that?
No, you can tell.
Oh.
You can tell. She just decides the speed. I even told her. I was like, because we were driving with someone else, and the other girl, she had like 360, and her mom called her and was like, why are you so, because her mom was in front of us, and so she was like, why are you going so fast, like this and that, and I was like,
I had an Indian.
Mom, why are you going so fast?
I had a buddy in college. He was from India, and man, that guy had so much money. He had a Mercedes, and I was driving it from Kingsville to the Valley, and you cannot tell how fast you're going on that car. You cannot. I got pulled over The clock, I don't remember anymore what the speed was, but it was above 100. And the cop was like, "Why were you going so fast?" Like, I didn't even know I was going that fast. You know, those Mercedes are just like so silent. You can't even hear the wind going through. Just like, shh. And I just see the lights in the back, and I'm like, "Oh my god!" Yeah. So if I'm not gonna buy Mercedes. It's too expensive for me. I'm just a teacher. But if you get a chance to drive a Mercedes, guys, you can't even tell you're going fast on that. Shh. All right. Oh, and a truck I can tell. My truck, yeah. Well, it's a brick, miss. It's a brick. Yeah, if you're going 70, 80, I can hear the wind in my truck. Okay. All right. Sorry, guys. Here we go. So these are the questions that you're going to get on UH Quiz 3 and Quiz 4. So it says, give the value of a and b for the function f of x to be continuous at both x equals 1 and x equals 6. So here we go. For me to be continuous at x equals 1, I need this guy right here to equal the 15x. So I'm going to do it informal. Do you guys want me to do it informal? Okay, informal. So I'm just going to plug in a 1. A times 1 minus b equals 15 times 1. So a minus b equals 15. Is everyone okay with that? Okay. So now I need to be, for it to be continuous at 6, I need the 15x to be equal to the bx squared minus x. Bx squared minus a, sorry. So here we go. 15 times 6 equals b times 6 squared minus a. Here's equation 1. So what's 15 times 6? 15, 30, 60, 70, 80, 90. Is it 90? 90 equals 36b minus a. This is equation 2. I think I'm going to solve for a on equation 2 and plug that into equation 1. So you're done with calculus. Now you're just doing algebra. So from this one, I'm just going to change. What am I going to change? I'm going to change these two numbers. So a equals 36b minus 90. And I'm going to plug that in right there. So I'm going to write 36b minus 90 minus b equals 15. 36b minus b, that is 35b minus 90 equals 15. Plus 90 plus 90, 35b equals 90, 105. And then divided by 35. No, you're good, miss. You're good. Ask. I just subtracted 1b. 30, 60, 90, 5, 10, 15. So 3. I do it in pieces. Now, okay, I'll slow down. Now that I know what b is, can I solve for a? It does not matter which one you use. Matter of fact, I'm going to use equation 1. A minus 3 equals 15. So add 3, 16, 17, 18. There we go. You would have gotten the same answer if you would have used letter A. Say it again. Because I didn't. Okay, why is it informal? Do you see anywhere written the word limit? The formal way would have been for you to do this. Limit as x approaches 1 from the left of ax minus b better equal limit as x approaches 1 from the right of 15x, which better equal f of 1. And then I solve. That would have been the formal way. Does that make sense? And of course, you got to do the other one as well, right? Limit as x approaches 6 from the left of 15x. Better equal limit as x approaches 6 from the right of bx squared minus a, which better equal f of 6. And then you solve. That's a formal way. I just did it informally. Cool or not cool? What's up, Henderson? Hit me. Go for it, Rodriguez.
Oh, you're just looking for A.
Yeah, if A is 18 and B is 3, then that will guarantee that the top, ax minus b, will equal the 15x. Like the y values will touch. And because there's an equal sign on the top one, if the y values touch, then that means I'm continuous. Because the limit equals that value. You want me to just plug it in so you can see? Sure. Yeah. Okay, look, check it out. Equation 1, 18x minus, what was my b? 3. Check it out. If x equals 1, I'm going to plug in a 1. So I'm going to go f of 1 equals So 18 minus 3, I get 15. So that's my y value for the top one as x approaches 1. That's my limit from the left-hand side, right? Okay, my limit from the right-hand side. So look, limit as x approaches 1 from the right-hand side of 15x. Oh, look, it's 15. And then f of 1, when I plug in a 1 into this equation, I'm using the top one because there's an equal sign, 15. So check it out. From the left, it's 15. From the right, it's 15. And it equals 15. I know I didn't put the limit in there, but do you see how it's working? Okay. What do you think, Ms. Kyle? Do you approve? Okay. I just thought of something. And okay. No, don't worry. I know you guys are seeing my notes and you guys are writing them down, but sometimes you guys don't reference the notes because some of you guys on the UH quiz, when you got this question, I'm just making up the question because I remember it. I remember it. Let's see. Let me go and do this. Square root of x. Okay, so the x approaches 49. Square root of x plus 7 over square root of x minus 7. No. Let me do x minus 49. There we go. Hold on, let me do that. Yeah. Oh, they're just doing juniors right now. Some of you guys, when you guys get to this question, you go, which is fine, square root of x minus 7 over square root of x. But what's a bet? Well, I don't know. I think it's better. I don't think. Yeah, difference of squares. Square root of x times square root of x, and then 7 times 7. And this is what we did in the notes, but then you revert back to, and I know why you revert back to it, because you did a whole bunch of delta math, and all the delta math, none of them, the delta math is not human, right? The delta math is never going to do it like this. They're always going to do it like this. So you're just referring back to what you've been doing over and over again, but you have notes. You can, okay, sorry, I'll stop. No, hey, miss, it's with love. It's with love, I promise. Okay. All right, this is not even really calculus right here. This is just more algebra. It says solve the inequality. So all this means is, where is this greater than 0? So I like to do railroad tracks on this. So just find where this is 0 first and foremost. So I see that as a 5 there. 4 times what will give you 28? 7. So this is x equals 7. 7, 14, 28. So there it is. So I'm going to do railroad tracks. And I'm going to put 5. And I'll put 7. Yeah, we have done this before. This x minus 5 with a square on it, we're not even going to look at it, guys, because it's always going to be positive. Do you guys see that? So I'm just going to plug in a number to the right of 5, and I just care about this one right here that I'm circling in blue, because that one is a linear term, so that one is going to be positive or negative. So if I plug in a 0, 28 minus 4 times 0, is that positive or negative?
28 minus 4 times 0.
Positive. Yeah, just positive, so I'll put a plus symbol. Give me a number between 5 and 7. 6. 4 times 6? 24, right? 6, 12, yeah. And then 28 minus 24? 4. So that's positive. You just care about positive or negative. Give me a number bigger than 7. Any number. 8. 4 times 8? 28 minus 32? There it is. So this wants to know, solve the inequality. Notice there's not an equal sign. So where is this positive? Well, it's positive between negative infinity all the way to 5. Notice I put a parenthesis there. Union from 5 all the way to, and there it is. Why isn't it what? Oh, because there's no equal sign. It just says greater than. So there is no bracket on the 5s, because if there wouldn't be equal, right at 5 you're 0. It equals 0. But there is not an equal sign, so we leave it with parentheses. Does that make sense? No, let's find it. Let's find it. Critical numbers, or let's find where this equals 0. It equals 0 and x equals 5. And well, these are vertical asymptotes, so we have to write them down just in case. And x equals 2 and x equals 8, because those are infinite discontinuities. So here's my railroad track. All right, here we go. I'm just gonna choose numbers. If I'm like at 0 in the top, I just care about positive or negative. So just hold on to your memory. So in the top, if I plug in a 0, I get a negative 10. So put that in your memory that you have a negative 10 in the top. If I plug in a 0 here in the bottom, I get negative times a negative, which is a positive. So I have a negative divided by a positive, which is, so put a little minus sign. Give me a number between 2 and 5. 3, 4, it does not matter. So I'm going to plug in a 3. 2 times 3 is 6. 6 minus 10, positive or negative? Okay, put that in your memory. Negative in the top. If I plug in a 3 in the bottom, 3 minus 2, positive or negative? 3 minus 8, positive or negative? Positive times a negative? So that's what I have in the bottom. What did I have in the top? I already forgot. Negative divided by negative? Put a plus. Give me a number between 5 and 8. 6, 7, 8. Oh, 6, 7, 8. Oh, is that not it? 6, 7. All right, here we go. If I plug in a 7, 2 times 7 is 14 minus 10. Is that positive or negative? Positive. So I have a positive in the numerator. 7 minus 2, positive or negative? 7 minus 8, positive or negative? Positive divided by negative. Put a minus sign between 5 and 8. Give me a number bigger than 8. 10. 2 times 10 is 20. 20 minus 10 is a positive number, 10. So I have a positive in the numerator. 10 minus 2, positive or negative? 10 minus 8, positive or negative? Positive divided by positive? Positive. All right. What does this mean? What do they want? They want, if it says less than 0, that's a demerit. That's what you saw. If it says less than 0, they want a negative number. Does that make sense? All right. So where is it negative? Negative infinity to 2. Put a parenthesis. And where else? 5 to 8. No brackets anywhere. That's where it's negative. Yes, S. Because you see how it's squared? It's always positive. Yeah. All right, guys, we're done. There's a delta math. It's not too long. The estimated time, I think, was 25 minutes. And then you'll probably get called out next for pictures. So let's see how much we can do. I think I put it due today. Or maybe to put it due tomorrow.